Flip now to the spot for his second.
Oh!
Lays it off.
And it's a hat trick for Suarez! I forecasted many weeks ago that they'll do this! I forecast they will be setting each other off penalty kicks! And what we have seen here is absolutely Shakespearean! The Shakespeare got it wrong! It wasn't King Lear, it's King Leo! The assist from the penalty kick recalls the great...
Cool, right? Kicking around a ball is such a basic and human nature activity that perhaps even mankind's earliest ancestors were kicking around a ball for entertainment. It was revered in the Americas and Europe, for it was there where the game truly took form. The origins of the sport are murky, and no one is sure where the concept may have started. But one thing is clear. For thousands of years, soccer has been immersed in global history, with its earliest origins originating as far back as 2 or 3 CE. The sport has always required much skill though. The early Chinese claimed themselves to be the originator of the sport, with records of men kicking around a leather ball filled with feathers and hair as part of a military drill, without the use of hands, and kick the sphere into a bamboo goalpost. Recorded facts also support the fact that Romans and Greeks used to play ball for fun. Some facts point to Kyoto in Japan, where kicking of the ball was a popular sport. Regardless of whoever started the sport though, the game was truly transformed into what it is today by the British. Some amusing facts even mention that the first ball used was the head of some Danish brigand. It is said that during medieval times, the old form of soccer used to allow many ill practices, like kicking, punching, biting, and even gouging. Sometimes the competition grew so fierce and the masses got so wild that there were frequent incidents of violence during the game. It is also said that soldiers admired the game so much that they missed archery practice just to watch it. In fact, it was so prominent that King Edward III banned soccer in 1365 because of the growing incidents of violence and military indulgence in the sport. In 1815, English school and Eton College came forth with a set of rules, known as the Cambridge Rules, where schools opted for rules similar to rugby, such as prohibiting tripping, shin kicking, and carrying the ball. In October 1863, 11 representatives from London clubs and schools met at Freemasons' Tavern to set up common fundamental rules to control the matches amongst themselves. The outcome of this meeting was the formation of the Football Association. Firmly establishing the foundation of soccer in 1869, the Football Association strictly banned any kind of handling the ball. No other sport events besides the Olympic Games today can compare itself with the FIFA World Cup though. The event was established in the year 1904, and by the early 1900s, football was introduced as an exhibition sport and became the first team sport included in the Olympic Games. Since 1908, the sport has been held at every Olympic game with the exception of the 1932 Los Angeles Games. Nevertheless, the fact remains that for as long as people have lived, they have enjoyed kicking a ball with their foot, seemingly less of an aberration than throwing a ball around using the hands. In 1997, in a game between France and Brazil, a Brazilian player named Roberto Carlos set up for a 35-meter kick. There was no seemingly way possible to get a goal. He placed his kick on the lower right corner of the ball, sending it high and a bit to the right, but also rotating it around its axis. The ball started its flight in an apparently direct route, with air resistance on both sides, causing the ball to slow down. But on one side, the air moved opposite to the ball's spin, increasing air pressure on that area, while on the other side, the air moved in the same direction as the spin, creating an area of low pressure. That difference between the two sides caused the ball to curve towards the lower pressure zone, or in other words, the ball experienced the Magnus effect. And this effect explains the side force on a sphere. This curved path is also more commonly known as the banana kick. As friction and other opposing forces act upon it, the spinning motion causes the air on one side of the ball to move faster, confusing the goalie and opponents as to where the ball will exactly land. But it is tedious to get the ball into the air and bend around into the goal. Too high and it soars over the goal. Too low and it hits the ground before curving. Too wide and never even reaches the ground. Not wide enough and the defenders can easily intercept it. Too slow and it hooks too early or sometimes not even at all. Too fast and it hooks too late. In a free kick, players want to use as much air resistance as possible because they want to curve and trick the goalie. To get a precise kick, players must use a certain velocity and a particular spin. The object in motion must be in a fluid, and in soccer, air is that fluid. It rushes around the ball on all sides, but the side turning into the air is noticeably slower than the opposite side. This is because of Bernoulli's theorem, which states that the fluid pressure decreases at any points that have higher speed in the fluid. Projectile motion is the motion of an object in air while moving, subject to only acceleration of the ball. A projectile is any object with a given initial velocity and has gravity acting upon it. The path of the object is determined by using its trajectory. The trajectory of an object is the curved path that the object follows when it is thrown into the air. This path is broken up into two components, the x and the y, which both have direction and magnitude. In soccer, the ball has a both vertical and horizontal component because it follows a trajectory when it is in air because of gravity and how it falls back down. So this is an example problem for possible projectile motion problem. So here's the problem. I kick the ball, which experiences projectile motion with an angle of 53 degrees to the horizontal. Its initial velocity is 10 meters per second. Find the horizontal displacement, the total time, and the maximum height of the ball required to do this motion. So I drew a diagram here to represent the problem. So I have the horizontal component here labeled and the vertical component here labeled, and I have the initial velocity and the angle that it makes. So we are trying to find the max height, the total time, and the horizontal displacement. Also, something to note here is that sine of 53 degrees is equal to 0.8 and cosine of 53 degrees is equal to 0.6. So there are three steps that we are taking to solve this problem, and here's the first one. So first we separate our velocity into its components to make the problem simpler. So here we have the horizontal component and the vertical component, and we have the velocity that the ball travels and the angle that the ball travels. So from that we have these two different equations. We have Vx is equal to velocity times cosine of 53, which is equal to 10 times 0.6, which is further equal to 6 meters per second horizontally. And Vy is equal to velocity times sine 53, which is equal to 10 times 0.8, which is equal to 8 meters per second, our velocity in the vertical direction. So then we solve for the vertical part first, since we need the time for all the equations that we're going to use. So here we have velocity is equal to initial velocity minus gt, and 0 is going to be our final velocity, and 8 is going to be our initial velocity. And for gravity, we're going to be using 10 instead of 9.8 just to make our calculations easier. So since it's moving down, it's going to be negative 10 t. So then we solve for t, and we get 0.8 seconds. But 0.8 seconds is the time required for only half of the trajectory, so we multiply it by 2 to get the other part. So our t total is 1.6 seconds. Then we move on to try to find the maximum height. And for that we have the equation h is equal to 1/2 gt squared. So then we just plug in and chug all our values in. So h is equal to 1/2 times 10 times 0.8 squared. And that is further equal to 3.2 meters. And in this instance, we are only using 0.8, which is half the trajectory, because Here we only care about the vertical motion. The last and the final step in solving this problem. Obviously, the more complicated the problem you have, or the more things you are trying to find, the more steps you are going to have. But for our purposes, this is our last step. So here we are trying to find the horizontal displacement. So we have the equation x is equal to velocity times time. So we have obviously the time from before, so we just plug in the values again. X is equal to 6 times 1.6, which is equal to 9.6 meters. And in this case, we are using the whole time because we do care about the horizontal component, because obviously it's going to exist throughout the flight, so it just doesn't just go from 0 and ends at 0, it goes from 0 and ends at 9.6 meters.
Momentum is the tendency of an object to keep moving as it is moving, and follow Newton's first law, which states that an object in motion will stay in motion unless acted upon by an external force. Impulse, on the other hand, is a change in momentum, and the relationship is defined between impulse and momentum. Force times change in time equals mass times change in velocity. The impulse-momentum theorem states that momentum will change if the system has impulse acting upon it. Players also wear shin guards as a typical soccer uniform, which acts as an important factor in impulse. The guard's form or fabric is somewhat of a shock repellent when it softens the blow of a kick and reduces the time of impact. In an impulse equation, if the time decreases, so does the total impulse, which is momentous in saving a player from injury. Likewise, players also sometimes deliberately try to shoot for the net, even though aiming for the poles of the goal gives an advantage over the goalie. When the ball hits the net, it increases the time of impact, decreasing the force and therefore allowing the ball to gently hit the ground. Clearly, impulse and momentum are huge factors in the physics of soccer. Few other sports show examples of passion to that extent as football or soccer. The arenas are flocked by cheering people, and in front of television, even more watching carefully, sometimes with great enthusiasm. And soccer is worthy of all that and much more.